In this session, we'll discuss about the sinking or settlement of support or yielding of support for the propped cantilever beam. So here you can see in the figure a propped cantilever beam of support, fixed support at A and a prop at B, and there is a point load W at C. So due to this point load, a settlement has occurred at B. Let the settlement be delta. So settlement occurs when the downward deflection due to load is greater than upward deflection of the prop, that is YB1 is greater than YB2. That means when YB1 is greater than YB2, then the settlement occurs. So YB1 minus YB2 equal to delta. Delta is nothing but yield of prop or sinking of prop or settlement of prop. So in the analysis of propped cantilever beam, we have few steps, like the first step is to calculate the deflection YB1 due to the external load only, removing the prop. In the second step, we will remove the external load and we will calculate the deflection due to the prop, that is YB2. And in the third step, we will equate YB1 equal to YB2. From there we can calculate the reaction RB. This is in the case of no settlement case, but here the third step is not YB1 equal to YB2, it is YB1 minus YB2 equal to delta. So we will understand this more clearly with the help of a problem. So we'll see example here. Analyze the propped cantilever beam of span 10 meters which carries a point load of 15 kilonewton at the center of beam. The beam propped at free end. Find the reaction of prop if it sinks at 32 mm. So delta is given as 32 mm, that is 0.032 meter, and RB, you can see the figure there. Propped cantilever beam subjected to a point load 15 kilonewton at center. So total span is 10 meter. We need to find RB, reaction at the prop. So the first step is to calculate the deflection YB1 due to external load by removing the prop. So you can see that in figure we have removed the prop and we have calculated YB1. Prop is not shown there. Okay, YB1 equal to AX bar by EI. So A is nothing but area of bending moment diagram into distance, X bar means distance of B from centroid divided by EI. So now we will calculate the bending moment values to draw the bending moment diagram. So bending moment at section XX between C and B is 0. So bending moment XX at AC is minus 15 into X. So at C, that is at X equal to 0, bending moment at C equal to 0. At A, that is at X equal to 5, bending moment at A equal to minus 75. So we can draw the bending moment diagram as shown in the figure. Then X bar. So area here is half into 5 into 75. X bar is 2 into 5 by 3 plus 5. So 2 into 5 by 3 plus 5 is the X bar. So YB1 equal to A into X bar by EI. Then we'll get 1561.875 by EI. So in the next step, we'll calculate the deflection YB2 due to prop removing the external load. So you can see the figure there. Due to the prop, the deflection YB2 is shown here. YB2 equal to AX bar by EI. Bending moment is calculated. So bending moment values, bending moment at B is 0 and bending moment at A is 10 into RB. So YB2 equal to area of bending moment diagram. Area of bending moment diagram is half into 10 into 10 RB. X bar is 20 by 3 divided by E. 20 by 3 from B. Yeah, divided by E. EI. So YB2 equal to 333.33 RB by EI. Step 3. So step 3 is YB1 minus YB2 equal to delta. So 1561.8 divided by EI minus 333.3 by EI into RB is equal to 0.032. Therefore RB equal to 4.6 kilonewton. So if we want to find RA, we will apply sigma Fy equal to 0. So RA we will get as 10.3.